Welcome class, we're going to talk about one that section 1.9 because we covered it, but we're actually just going to review it in class. So that's inverse functions, and 1.10, that's mathematical modeling and variation. Now in the book, there's a lot of word problems that come from this. And actually what we're going to do instead of do those word problems is we're going to primarily rely on delta math for this. So if there's any issues with that, namely that we don't get to those word problems, it's not a problem because the ideas, key concepts of direct variation, inverse variation, joint variation are all just there. Now, there is this thing with regression lines at the beginning of 1.10, which, if you notice, is right here in these three definitions. I'm not going to cover these three definitions. What I am going to do is actually create this idea of statistics. So I'm going to create it in the quiz today. You can tell me whether you would like to know statistics. Now, learn some statistics. Now, the idea is because in college, statistics is so important, but in pre-calculus and before this, we didn't really cover it in detail. So this would be something extra. This would be kind of like a math elective. Now, does it count for credit? I have not gotten through it yet. We'll talk about that and see what we can do. I just think it is an important concept and would be beneficial for anyone. So let me know if you are considering wanting to learn some more about statistics. But nevertheless, so we have 1.9, there's this inverse functions. So I want you to know the definition. I want you to be able to figure out inverse functions and what can't be inversed, and how to strictly them. So we'll talk about 1.1. So this is actually what's going to be on our Zoom call, and then we will come into 1.10. So statistics and linear regression. I'm basically going to tell you that you need, this is the key points. So let's not hold this. You need to, one, know how to plug in data into a table, and this is on either Desmos or a scientific graph calculator. You need to know how regression lines relate to the data. Now, there's actually regression lines that are useful and ones that are not as, and there's actually this thing called R-square, which I want to cover in definitely more detail. So again, at the end of this video and at the end of this section, I want you to answer the quiz and let me know, do you want to learn more about statistics? Because it is useful. It is definitely an important thing. But the problem is, again, I don't like how this is laid out, where you're supposed to model something very quickly and not go. Yeah. So again, we are only saying these two statements. You do need to know how to put it in the table, and we'll talk about this in class, putting it in the table and knowing how to plot regression lines on decimals. Okay. If you have a graphing calculator, you may need to look up a YouTube video for it. Okay, direct variation. Direct variation definition means that they will be proportional without any added number, but also where there is a constant attached to it. So these are all the same statement. These all mean the same thing. So y varies directly as x. So that this statement means the same thing as y is directly proportional to x. Okay, those both mean the same thing. And 3, that y equals kx for some non-zero constant k. Additionally to this, you will see that that k is the constant. Right? I will use that constant of variation. That just means it's going to tell you how we're varying it. It's just constant. It's one number. Okay? For the constant of proportionality. Okay? It's the constant variation over the constant proportionality. Now, instead of going into example 3 and 4 right away, we're going to go to direct variation as n power. And the reason is because we're just going to write the definitions and then talk about it later. So, what we're going to have is y varies directly as the n power of x. Okay, it's going to have the same idea here. Y is directly proportional to the n power of x. Okay, these are all identical statements. Finally, y from y equals kx to the n power, so x is to the n power for some constant k. Okay, now we're going to look at 3 and 4. Sorry, this is having trouble typing it. Let me zoom in a little more. See it? Okay, and I'll go back up. Need this, so I just use it. Okay. Okay, example 3 and 4. Okay, example 3 says, I'm just going to have the book here. This is right here. So it talks about in Pennsylvania, the state tax is directly proportional to gross income. You are working in Pennsylvania and the state deducts $46 for a gross income of $1,500. Find a mathematical model that gives Pennsylvania state income tax. So what we do is we model it. So that means state tax, the income tax, equals some k times our gross income. Okay? And if we write this out, we get variation. Let's just call this y. Y equals k times x. Okay? So y equals k times x. Now what do we get in information? They gave us that y equals 46.05 and x equals 1500. So what do? We set it up. 46.05 equals k times 1500. And if you do the math for k, you get k equals 0.0307. Okay? So that's problem 3. Problem 4, simply put, they say the distance a ball rolls down the incline plane is directly proportional to the square of the time it rolls. So we get distance equals k times the time squared. Okay? This is equals k times time squared. And what do they give us? They give us that during the first second the ball rolls 8 feet. So what's that have? So we get 8 equals k times, this is the first second, so 1 squared. So what do we get? That gives us that k equals 8. Okay? So that's, okay? Now let's talk about inverse variation. Okay? Inverse variation is going to be the opposite of what we just covered. And let's talk about that in the next video. Okay? Thank you so much.